So we're talking about function notation. So function notation means that y is a function of x or that y depends on x. So we're saying that y is the same thing as f of x. So y equals f of x. In this case, y is the dependent variable and x is the independent variable. Y is dependent upon whatever x is. X is independent, we choose what x is, and then we figure out what y is through that. All right, so let's look at some problems. So we're looking at example 1. So y is equal to 4x plus 3. This would be the same thing as f of x is equal to 4x plus 3. So y and the f of x, same thing. So I'm just rewriting it with the function notation versus just the y. So if we write f at 1, this means x is equal to 1. So here's our f of x, f at 1. That means the x is equal to 1. So we're going to plug 1 in wherever x is. So then we would have f at 1 is equal to 4 times 1 plus 3. Oops, sorry. So 4 times 1 is 4 plus 3, and 4 plus 3 is equal to 7. Now, this also gives us a point. When x is equal to 1, y is equal to 7, because f of x is the same thing as y. So this also means that when x is equal to 1, y is equal to 7. So that's a point. All right, let's do f at 2. F at 2 means x is equal to 2. So we'll have 4 times 2 plus 3. Following our equation, we just plug in 2 for our x. That gets us 4 times 2 is 8 plus 3. 8 plus 3 is equal to 11. So this point would be 2, 11. If we did f at negative 1, this would be 4 times negative 1 plus 3. 4 times negative 1 would get us negative 4 plus 3, and negative 4 plus 3 would be equal to negative 1. This point would be x is equal to negative 1, y is equal to negative 1. So you're just plugging in values for x to find y. And again, that's why x is the independent variable, but y is the depends, because it depends on whatever x is to what y will equal. All right, let's go look at example 2. We want to find f at 1, f at negative 2, given that f of x is equal to 7x squared minus 3x plus 1. So let's go find f at 1. Would be 7 times 1 squared minus 3 times 1 plus 1. So 1 squared, that's 1 times 1. So 1 times 1 is 1. Negative 3 times 1 would be negative 3, and then plus 1. 7 times 1 will get us 7, minus 3 plus 1. 7 minus 3 is 4. 4 plus 1 will get us 5. F at negative 2 will get us 7 times negative 2 squared minus 3 times negative 2 plus 1. Well, negative 2 squared is negative 2 times negative 2, because the whole thing is in parentheses. So that will get us positive 4. So 7 times 4. Negative 3 times negative 2 would be positive 6 plus 1. 7 times 4 is 28 plus 6 plus 1. 28 plus 6 will get us 34, plus 1 will get us 35. Now, one thing I want to point out for you is that if we're looking at this negative 2, understand that there is a difference between negative 2 squared and negative 2 squared. This has the parentheses, so the whole thing is squared, so negative 2 times negative 2. This one, just the 2 is being squared, so this would be equal to negative 4, because it would be 2 squared would be 4, keeping the negative. This one is negative 2 times negative 2, so this would be positive 4. So just understand parentheses do matter there, just to clarify. All right, so our next question or example, we want to find g of 1 and g of 0 given g of x is equal to 8x minus 2. So g at 1, we're going to plug in 1 wherever our x is equal to 8 times 1 minus 2. Gets us 8 minus 2, which is 6. So our point would be 1 comma 6. Oh, and on this last one, I did not do the points, did I? Sorry about that. So this would be 1 comma 5. X was 1, this one's 5. And this one would be negative 2 comma 35 if we're looking at the points. Just put your x and then whatever the y value ended up being. All right, let's find g at 0. So g at 0 would be 8 times 0 minus 2. Well, anything times 0 is 0. Minus 2 will get us negative 2. So this point would be 0, negative 2. On example 4, we're going to use our graph. So this is example 4. We're going to find the function values for the given graph. So f at 4, that means our x is equal to 4, so we go over to 4 and go up till we hit the graph, and then look over to see what y value that is. So f at 4 is equal to 2. So the point would be 4 comma 2. We're also going to find f at negative 2. So f at negative 2, we come over to the negative 2 for the x and go up till we hit the graph, and we see that it's equal to negative 1, or to positive 1. When we go up to the graph, it's at 1. So f at 2 equals 1. So the point would be negative 2, 1. And then our last one is f at 0. So x is equal to 0 right here, and when we're there, we see that y is also equal to 0, because they're both right there at the origin. So that means our point would be 0, 0.